Mastering unsupervised learning. Deep clustering ignores manual labels, unleashing raw data power. How does one effectively implement deep clustering, a type of unsupervised learning approach, to group data points into distinct clusters based on their inherent similarities and patterns? Implementing deep clustering, a type of unsupervised learning approach, involves several key steps to effectively group data points into distinct clusters based on their inherent similarities and patterns. Here is a detailed outline of the process. Step 1. Data preprocessing. Deep clustering begins with data preprocessing, which is a crucial step in preparing the data for clustering. This involves handling missing values, removing outliers, and normalizing or scaling the data. Normalization is particularly important in deep clustering, as it helps to prevent features with large ranges from dominating the clustering process. Techniques such as min-max scaling, standardization, or normalization using logarithmic or square root transformations can be applied. Step 2. Selecting a deep clustering algorithm. There are several deep clustering algorithms available, each with its strengths and weaknesses. Some popular algorithms include DPM, a probabilistic clustering approach that uses a deep neural network to learn a mixture of Gaussians. DEC, deep embedded clustering, a technique that uses an autoencoder to learn a lower dimensional representation of the data and then applies k-means clustering to the embedded features. Means, a clustering approach that uses a deep neural network to learn a hierarchical representation of the data and then applies k-means clustering. The choice of algorithm depends on the specific requirements of the problem, such as the size and complexity of the dataset, the type of data, and the desired clustering outcome. Step 3. Building the deep clustering model. Once the algorithm is selected, the next step is to build the deep clustering model. This involves designing and training a deep neural network architecture that can learn the underlying patterns and structures in the data. Autoencoders, a common architecture used in deep clustering is the autoencoder, which consists of an encoder network that maps the input data to a lower dimensional latent representation and a decoder network that reconstructs the original data from the latent representation. Convolutional neural networks, CNNs, for image data. CNNs can be used as the encoder to learn translation invariant and hierarchical features. The architecture of the deep clustering model depends on the specific algorithm chosen and the characteristics of the data. Step 4. Training the deep clustering model. The deep clustering model is trained using the preprocessed data. The objective of the training process is to minimize a reconstruction loss function, such as mean squared error or cross entropy, between the input data and the reconstructed data. Step 5. Clustering the data. After training the deep clustering model, the next step is to cluster the data using the learned representation. This involves applying a clustering algorithm, such as k-means or hierarchical clustering, to the latent representation learned by the deep neural network. Step 6. Evaluating the clustering results. The final step is to evaluate the clustering results using metrics such as silhouette score, calinski-harabasz index, or davies-bouldin index. These metrics provide a quantitative assessment of the quality of the clustering outcome, allowing for the identification of well-separated and dense clusters. Step 7. Refining the clustering model. Based on the evaluation results, the deep clustering model can be refined by adjusting the architecture, hyperparameters, or training protocol to improve the clustering outcome. This may involve fine-tuning the model, experimenting with different algorithms or architectures, or incorporating additional regularization techniques to prevent overfitting. By following these steps, it is possible to effectively implement deep clustering to group data points into distinct clusters based on their inherent similarities and patterns.